Alrighty, how's everybody doing? Good, awesome. All right, this is everything you wanted to know about logging. So, hi, I'm Charlie. I'm going to be your guide in the world to facts about logging. I am a senior director at GoDaddy. You can find me on the internet at that handle. It's the same on GitHub and Twitter. I gave a talk 2 years ago at Node Interactive. I actually used the same background slide called Modernizing Winston for Node 4. And it turns out that it's actually pretty hard to finish this. I'm actually really glad that I waited until Node 8 because the way that the API shaped up, it simply would not have been possible to do in a pre-ES6 era. And we'll talk a little bit about that in a minute. But for those of you who are, sort of looking like this, and you want the TLDR, the basic idea is that Winston is from 2010. Actually, it's January 17, 2011 is when that blog post is from. But I started working on it in November of 2010. So almost as old as Node itself now, right? We're in the sort of, if you did the percentage numbers, it's only 10% younger than Node or something at this point, maybe 12%. And back in 2010, 2009, using Node sort of felt like this. Just everything changed all the time. When people reminisce about, every release breaking things, I don't understand why they reminisce. It was actually really terrible. So things were a little different. There had never been one of these, right? There had never been a NodeConf. There was no streams API, right? That wasn't introduced until sometime in, I think, 2012. We take ES6 for granted, but back then ES5 was still new, right? So even basic things like, object.keys, that was a relatively new thing. Everyone was still using for-of loops and doing, object.hasOwnProperty everywhere in server-side code where you don't need to check for that. If you wanted to do any effective code coverage, your face just sort of looked like that because there weren't any good code coverage tools. Now we have great things like NYC and Istanbul, and I love using them. I wish I had them 7 years ago, but we simply didn't have them. I like to think of it as sort of an old-timey car. You had all these really fancy-looking dials. They didn't actually work that well. You're probably better off with the car you have today, but they looked pretty cool. So it wasn't that bad. So let's fast forward here. Let's go back to the future. By 2015, things were moving along. I think in 2014, we released Winston 1, which broke some of the smaller APIs, log levels, things like that. 2.0 had come out that year, which was a couple more breaks, but things that people were sort of used to. And the 3.0 API was pretty much done, which broke a lot of things. It didn't break the ecosystem, which we're going to talk a little bit about later. But the way that you do options and formatting is completely different. So it can be done. You have to really explain to your users why it's better, what's going to be better about it. But it takes time, it takes effort, it takes a lot of thought and consideration to what your ecosystem looks like. Also in 2015, we're getting about 2.6 monthly downloads compared to sort of the next largest library in terms of download popularity, assuming that downloads are a pure proxy to popularity or quality, which I'm not saying they are. So 5 times better than the nearest competitor. But I like to think of this as if you've ever heard this John Lennon quote. I like to refactor it for software. So if John Lennon did write software, it'd probably sound a little bit something like this. So let's just sort of ignore the last 2 years. There are reasons why it took so long. Part of it was actually a very hard problem. But let's just sort of jump back to the future again. Can we drop the lights that are closer to me, AV folks? Is that possible? All right, while they're checking that out, I'm going to just keep going. I know it's probably a little bit hard to see over here. I apologize for that. These are darker slides. So jumping forward to today, right? The 3.0 RC came out last week. Nothing like a little bit of conference-driven development to get things over the line. But besides that, even with 2.0 out and popular, the downloads are still good, right? I think probably the really weird spikes are NPM's reporting itself. because you can see the spikes are consistent across Bunyan and Winston. But Winston still sort of wins, in this world of like, what are people using? Why are they using it? And that was really perplexing to me as I kept seeing all of these blog posts and analysis of why it's so slow and these things are faster and better. And I was like, man, why don't people use those things? And it really had to go back to first principles. Why is this true? And so now we're going to jump into an analysis of those APIs. What is a logging library? Why are they useful? What do you really want out of them? So let's consider the API, right? Both of these are the Mona Lisa, obviously. No, they're not. So I like to call this Shakespeare's logging, right? A play in 5 acts. The first one, of course, that I'm sure everyone in here is pretty familiar with is these things. In sedimentary rock, they are different, levels of time. But for us, we just call them levels, right? You use them all the time. Info, error, warning, maybe something that you made up. If you've ever used NPM, they have an HTTP level, which they use just for dumping out the requests that they're making to the registry. So that sort of bespoke defining of those things is incredibly useful. The important thing about it is that you take into your heart of hearts RFC 5424, which is always right, no matter what you say or think, or if you want to be different, as we were pre 1.0 or 2.0. And it's actually very simple. Like, you can go read the whole RFC. It actually defines all of the syslog levels. But the really important part about it is the order of priority, right? Levels should be in decreasing numerical order, the increasing the number of priorities. So in both of these cases here, which is just totally impossible to see, this is going to make it rough, it's 0, right? So error in both of these cases, error and emergency are both 0, right? So you want to start with your most important level is actually the lowest number. Act 2, of course, is shipping your logs, which I'm sure everyone does by driving some sort of old-timey truck. And these things go by a lot of names depending on what library you're using, but the concept is the same. You have some object or string in memory, and you want to get it somewhere else, whether that be to your console or to some sort of file or to some remote server. In Winston, we call these things transports. If you've ever used Bunyan, they're called streams. If you use Log4j.s, they're called appenders. But they're all the same thing. And thankfully, I think now with Winston, maybe Log4j.s is still a non-pure stream API, but it should all be streams, right? We have this pretty awesome API that, especially in the post-streams 3 world, as of, I think, Node 12, 10, Node 4, that sort of land. Not like anyone's using those versions anymore. But it gives you back pressure, right? So if you're reading from memory and writing to a file, you get those nice sort of buffering things out of the box. That's why the memory transport in Winston went away, because there's no need for it. It just is a stream. A stream has back pressure. It has all the things that you would do and want out of buffering. So I like to say in Winston 3, a transport is just a writable stream, right? Get a stream just like any other stream, do things with it. It's actually a really nice, concise API. The internals of Winston are a good example why writing stream APIs is really, really hard. You probably don't want to do that yourself. Of course, Act 3 is now that you've put these things somewhere, you actually need to query them and do something with them, which is querying and streaming, right? You want to do some sort of historical analysis on your logs, or something's on fire in production, you want to get the stream of a current log set off a server. Like, oh my God, the server's on fire, just show me the logs right now in real time. You're probably going to end up using Kibana or some sort of SaaS that you use. On the streaming side, it depends on where you're deploying these things. If you're using Kubernetes, maybe you're getting that stuff through, was it FluentD is the popular thing for that now. Trying to do this in a bespoke way always ends tragically, like almost always. So you probably want to use something else for this. Kibana's worked out well for us. There are a number of SaaS services that do this. Trying to remember log entries, Logly, those types of things, and they're reasonably priced. Next to last, really Acts 4 and 5 are 2 parts of the same act that are going to lead to our logical conclusion for this. Here we're taking some sort of in-memory representation of these fish and printing them out to paper, i.e. we are serializing them, right? So fish image becomes fish paper, same idea with logs, right? You have some object, what does it actually get represented as? It is some string that is info, i.e. the level, followed by the message, followed by everything else that you logged. Is it JSON? Is it pretty printed, right? What is the final representation of the string, the buffer type in Node that's going to get written out? Because all your transports should only care about that thing. They don't need to care about the rest of the object. You should already be done with the serializing and filtering by the time it hits whatever is going to ship your logs. So things that fit in this space are like, is it going to be JSON? Do we do coloring? Are we pretty printing it? Do we like align our levels? Do I have any other custom formatting that I want to do? Should I add a timestamp? This is where all of the complexity is for people in their own apps, where they're trying to do something that is by definition bespoke. They want their logs to look a very particular way. And after 7 years of doing this, people really want their logs to look a particular way. If they don't look exactly the way that they want them to, they're going to be very cranky. Act 5, of course, is the last and really the most important one, combined with Act 4, is that you want some sort of default values, and then you need to mutate values down the road, right? So you write something, and then you've written some other piece of logic that says, oh, well, if I log this, then transform it in some way into some JSON-friendly thing, like I logged a request, so I'm going to turn that into a JSON-friendly thing down the road. Bunyan calls these things serializers. If you've ever used Morgan, they call them tokens. In Log4j, they called patterns. I think they're also called serializers in a few other libraries. But basically, like, if there is this key of this name in the object that you log, then do this transform on that key and then put that back in that object. So this leads us to, with 4 and 5, you can really end up here quite often. And for those of you who can't see this, this is the robot devil from Futurama, right? So you end up in hell. And I like to refer to it as options hell. And it is at least the 5th circle of programming hell. It might be the 6th circle, I'm not sure. It is not a fun place to be. And I'm going to explain that a little bit in code that's going to be really difficult for everybody to read. Again, I apologize, I didn't know this room was going to be this bright. But I'll put all these slides up later. You can sort of see what I'm talking through. So in the original versions of Winston, there was this method called common.log, which everyone used. It was the default serializing logic. You'd give it some sort of object, which you can see here. No one can, oh my God, this is impossible to read. So yeah, this is great. We're going to do it live. Great. Okay, the yellow makes it readable. Awesome. So you can see there's just like, okay, there's some object that, level, message, maybe some metadata. Do we want to colorize this thing? And this is actually the docs that I wrote like 6 years ago. And at the time, that was reasonable. It's got like 6 things. Oh, it's a little internal helper method. Great, sure. Everybody's happy, move on. Over time, that grew into this horrible monstrosity of features from everybody in open source land who wanted their very particular logging feature. And you're like, oh, that, independently over time, they all seem reasonable. Oh, that, you want to add log stash formatting to it? Sure, that seems reasonable. 30 features later, you have this unmaintainable behemoth that makes every single transport look like this, right? So you have to pass in all of these options everywhere, and it is a complete nightmare. This is what I mean when I say options hell. It's basically because there is some new option, you can't just do it at the user level, at the consumer level. You have to do it in the framework, in the transport, which is really, really painful. So solving this problem was the main motivation of the rewrite, because this had been the main source of pull requests for multiple years. Everyone, they're like pretty happy, everything works, they get their logs, but oh, this very particular formatting thing that I want, that's not there, so let's go make a pull request for that. And so how do we turn that idea into something that they can just do on their own, maybe have some shareable way to do that, and that is what formats are. So formats are basically streams. They're not quite streams because they don't need back pressure. You could think of them as transport streams with no back pressure. And they are very, very small functions that you can combine that are supposed to be your final formatting, right? They define the serialization. So instead of passing in that colorize option, I can now just use this colorized format, which at the end of the day will serialize things. So if we go back and remember this code that no one can read, this is actually of course, no one can read the comment of what file this is. And that is the console transport in Winston 2 and below. And so the console transport in Winston 3 is this. There's nothing to it, right? You say, okay, look, I'm going to look at the object that you've given me, and if, oh, thank you so much. And if the level is something that should go to std_err, then I'll write it. I'll write the final serialized thing, which is a symbol message. We'll talk a little bit about symbols in a minute. And we'll just write that and then invoke the callback. So this is the entire transport code. You just write the serialized thing. You shouldn't care about any of the internal object methodology. From a performance perspective, this is completely a la carte, right? Like all of the expensive things that were happening in Winston 2 were all this formatting stuff, all these checks for options that never existed in your logs. So now, because you don't even hit that code, you don't have to pay that price. So this is a good segue into this idea of performance and API design, because the main thing that kept coming up was like, man, why are people using this library? It's clearly much slower than the other options out there. Maybe it's better documented, maybe, not sure. But I think that this idea of performance being the end-all, be-all isn't quite what people want, right? Like, what are their motivations? What are their desires? And so when you focus on performance as the end-all, be-all, you sort of end up with something like this, right? Where I'm sure that car is very fast. Maybe it's not the most practical thing in the world. So in other words, it turns out that performance is simply not everything. And I don't know if the reason why it's not everything is a good thing or a bad thing, but it turns out that I think developers want this. And if you've never seen this episode of The Simpsons, Homer Simpson designs his own car and becomes this horrible tragedy, and over there is his brother. So, in this analogy, the customer is in the car, and I'm there standing, being like, okay, well, I guess this is what you want. So, and it really does turn out that developers want the Homer car, because those highly performant, highly specialized things are not general purpose, right? Like if you're going to go use something that just logs in JSON and you're writing a CLI tool, well, now I can't use that thing. So now I have to go find another logging library that will work for my CLI tool, and then that search process is itself more work than later caring about these things. So, once we think about formats, hopefully everybody's happy, right? The core log plumbing is very, very fast, and you can define your own formats. Who cares what performance price you pay for those things on top of it? Here are a couple of examples. This is the colorize of things. You say, look, depending on what you want to colorize, I'll write to the level or the message, and I'll overwrite those things. And you notice here that they're properties. They're not the symbol lookups, and that's very, very important. We'll talk about that in a second. Here's another one. This is, pretty printing. And here you'll see that there's this symbol, right? So when you actually want to write the final message, the thing that you want to get shipped to wherever it's going, you use that symbol. And so in this way, you can make, say, the levels, right? You can make those mutable, because when you write the final message, you want the level to be colorized. But you don't want that to affect your filtering, right? You don't want all of a sudden nothing to show up, because the log filtering and the priorities are specified by that string. So you need an immutable copy of that string. Same goes for JSON, right? I know there's faster JSON libraries out there. So like if you wanted to, you could just write your own JSON fast format or something, and then you don't have to contribute anything back. You can just make that yourself. Everybody's happy. And there's very, very little maintenance cost, which is what we were optimizing for. So in retrospect, this sounds, of course, very, very easy. And it's easy in the way that you can see those people in the background. It looks very easy, but it is not all that easy. I went through a number of different iterations trying to figure out what the right way to do immutability was. If you've ever used weak maps in ES6 for a long time, my theory was that you could have these objects that were keys in the weak map and then look up the mutable things in there. That turned out to be incredibly slow. So eventually we ended up with something that looked sort of like this, lots and lots of symbols, right? Symbols everywhere. And symbols turned out to be a really, really good use case for this. There's just two of them. right? You symbol for message, symbol for level, right? So we set the level. You should be treated as immutable by the consumer. And then if you're writing something that is serializing or finalizing, you just use the message symbol. And that symbol.for is part of ES6. It is the sort of registry for symbols within your running process. So you can do that wherever you want. There's no coupling for those things. Symbols have less memory overhead because underneath the covers, I think they represent integers. They're non-enumerable, i.e. they are semi-private. So you can access them. They are mutable, but you shouldn't, right? And you won't be able to find them unless you know what you're looking for. And the biggest win here is that they are not going to appear in a default JSON stringify. So back to hell, of course, because that was only the 5th or 6th circle of hell. There was another really nasty hell that was in the original Winston code base, and it really strikes through a lot of logging libraries, which is why there's not a lot of interop between logging libraries. You ever wondered that? Like, man, why don't these things just accept the same object and then write them out? I don't know either. And I think it's because coupling is the 9th circle of programming hell. Like, it is just the worst thing in the world. And Winston was very, very guilty of this. It had everything was in one library. Transports used to depend on it itself just to define a transport, which is very silly. So how do we make that simpler? How do we make that easier for people? Decoupled shared functionality. There is now Winston Transport, which is, you can still access this thing as, winston.transports.transport, but underneath the covers, we're just exposing it from this require. So you should use that. There is also a not yet fully feature-rich test suite, which is an abstract Winston transport. So hey, look, you want to write a transport? Guess what? It's a transport, so it's going to have exactly the same test cases as every other transport. There's nothing really special about it. Maybe you construct it with some special options when you look at it here. But at the end of the day, it is just another transport. It calls a log method, it gets an info object, and it writes it somewhere, and then it's done. And even these formats, they're a separate module. So this is sort of code from inside of Winston itself. Like, yes, you can use winston.format, but it's just another library. And that's how we define those things. So there's also a really strong push towards backwards compatibility. So if you have a transport today, it is not going to break. You will probably see a warning message in your code somewhere that says, hey, this is a legacy transport. You should go bother the maintainer to update that. And they just need to do a little bit of work to make that an actual stream instead of just a prototypal object that has a log method. And that's relatively easy. There's going to be a full upgrade guide for that. Anyone who wants to use any of the old stuff, it's around as a Winston compat package. So it's got that horrible function. And this is important because the transports, right, they used that. Like, that was what they used for their serializing. So now they don't have to do that. But if you have an old thing and you're trying to at least make step 1 to upgrading it, you can stop depending on Winston, depend on this package, and then sort of release a minor version to make it easier for people to install your transport. So you're not installing 2 versions of Winston, doing a bunch of NPM installs that are unnecessary. It also has the original transport. It has a bunch of old test macros because there is an ancient test library that most, if not all, I'm sure a bunch of transports use because that's what Winston used. It doesn't anymore. So the benchmarks have been pretty kind to us. The folks who maintain Pinot did another benchmark against Turbofan, and it was actually even better. So these numbers are against Turbofan. So it's 4 times faster than it was. So that's pretty outstanding numbers. It's now faster than Bunyan. It's got a long way to go, but it's faster than the second biggest download out there. So it's something to do. So yeah, I mean that's really everything to know about logging. I think the last thing that I'll push for here is that I'm a big believer in paying your own debts. So this was a large chunk of technical debt that I had let happen for the better part of a decade. And so now that it is done, I'm actively looking for people to take over this project. This 3 feels like done. And if you're interested in that, it gets, I think now it's about 7 million downloads a month. It's one of the most popular projects out there. So if you're interested in that, please let me know. I'd love to talk to you about it. There's lots of good stuff. It's really the latest and greatest of what Node has to offer underneath the covers. And that, I finished about 4 minutes early. But that is it. It is not yet out. So, I mean, it's out, but you have to actually install it with a tag. So if you install Winston next, you'll get it. It's not the latest tag yet because it's still in RC. But we expect to be out of RC in a couple of days. It's really just, I wanted to get above 90% code coverage, and we're at like 75. So it's just writing a few more tests, and it's done. So thank you.